Saxon Algebra 1/2, Lesson 4. Welcome to my midnight math class. I am experimenting, you guys, with getting lighting so that I can record lessons at night because, as you know, I have delayed sleep phase. I keep unusual hours. And if I could record at night, oh my gosh, that gives me so much more time to schedule your lessons in and around everything else I have going on in the daytime. So I right now am experimenting with my daughter's ring light. She teaches English online to kids in China through a program called VIP Kid. And so she uses lighting at night too, because she's teaching in the middle of our night in order to get to Chinese daytime. So I'm experimenting with her lights. I'm asking you to give me feedback. Can you see the page? Does it look okay? Should I get this light or should I get more lights? I'm kind of thinking I need two, and I would have one shining this way and one shining that way. I think that would be better. I think right now it's a little cockeyed. But in any case, let me know what you think of the lights. I am going to share with you the magic of Lesson 4. It is about multiplication and division. Last time we reviewed addition and subtraction, and we talked about how addition and subtraction are something called inverse operations. As you probably already know, but I'm going to remind you, multiplication and division are also inverse operations. And this concept becomes very important in algebra because we use one operation to undo the other. So if we're adding something and we want to undo that, we subtract. If we're multiplying and we want to undo it, we divide. Blah, blah, blah. So this concept of these two pairs of operations undoing each other, which is the way I say it, being inverse operations, which is the way John says it, is cool and important. So we're going to come back to that again and again. We're going to start, though, with just a basic review. I know this is easy, you guys. I totally get it. We're just making sure that you feel really comfortable and confident with all the things you've learned in the past, and we build on it. So we're going to multiply a 3-digit number times a 2-digit number. We line them up on the right. I'm pointing that out to you because later in algebra, we're going to be lining some things up on the left, and that will be weird. So let me just point out to you that we line up over here, we justify on the right, and then we begin multiplying. We start here, and we multiply up and across to everybody in the top row. So 3 times 4 is 12. We write down the 2. We carry the 1. You know this. I'm just reminding you. 6 times 3 is 18. Plus 1 is 19. Down goes the 9. Over goes the 1. 3 times 1 is 3. Plus 1 is 4. 492. Okay, cool. Now we switch to the second row, and what we want to do is we want to recognize that when we do these multiplications, we're not multiplying by 2, we're actually multiplying by 20. So I put down a 0 right here, and then when I start multiplying, like 2 times 4, I'm going to put the 8 right here to recognize that this isn't really 8, it's 80. Okay, so that's what this 0 does for me, is it takes into account that we've shifted over a place. Okay, so we got 2 times 4 is 8. 6 times 2 is 12. We put down the 2. We carry a 1. 3. Okay? Now that we've got both of the multiplications done, we add. 2, 7, 7, 3. That's our final answer, right? Okay, cool. So that's basic multiplication. Like I said, I know you understand how. We're just refreshing. It's okay to forget. My job is to remind you. Now let's try a slightly different example. In this one, we're going to use money. $5.79. Let's say that you're a parent who decided to pay your children $5.79 per week, and you're paying, and you have 29 kids. Let's just dream big, shall we? Okay. So we have decimals in our number. The fact that this is money doesn't change the fact the really important thing is decimals. So step one when we're multiplying by decimals is ignore the decimals. All right, let's write that down. Anytime one of the steps is to ignore, I say let's write it down. That will be a good step to remember. Ignore decimals to multiply. Let's do that, and then we'll pay attention to the decimals at the end. Okay, if you guys were with me, I wouldn't have to do this myself. It's sad, but I have to do all the work. 9 times 9 is 81. 63 plus 8 is 71. 9 times 5 is 45, plus 7 more is 52. See how I'm ignoring the decimals? I shift over to the 2. I put down the 0 to recognize I'm actually multiplying by 20, not 2. 18. 14 plus 1 is 15. Notice how I'm squiggling out my old borrowings or carrying so that I don't confuse what I had for the 9 with what I'm getting for the 2. Okay, 14, 15, carried the 1, 10, 11. Right? Oh, here comes Gracie. She's going to join us. Hi, Grace. I'm in here, right? Usually I'm in a different room at this time of night, and she's like, what are you doing, woman? Okay, we multiplied. Now, we're going to put back the decimal. And here's the rule. I'm not going to try and write this out in words because it's such a simple rule, but it's so hard to say in words. We go back to our factors. Remember that the numbers that we multiply in a multiplication problem are called the factors. The answer is called the product. Okay? What we do is we count how many digits we had behind the decimal places in the factors. It could be both factors have decimals, or in this case, just one. And I say we have 2 digits behind the decimal in our factors. These two, the decimals right there. Okay, so in our case, the answer is 2. So we go here, 1, 2. We put the same number of digits behind the decimal in the answer. We put a $sign on it. We box that puppy, and we check to make sure it's right. Yay! Oh, life is so good, isn't it? All right. Division is our next topic. That was multiplication. Here comes B, division. Division comes naturally to any person who grew up with siblings, right? Because in your family, however many kids there are, like in the family where I grew up, there were 4 of us. I had 3 brothers. Well, I still do, but I had 3 brothers back in the day. I knew how to divide everything by 4, right? Because that's what we did all the time. So the number of siblings you have in your family, you're really good at that division. So dividing is the opposite of multiplying. It is something that can be confusing because we have a number of different ways to show a division problem. And so let me show you this one. It said the instructions are to divide, but the problem looks weird, you guys. This might not be the way you're used to seeing a division problem set up. What in the world? Why did I make it into a fraction? I know it's perplexing, right? But just remember that whenever we have a fraction, we can interpret this line as saying to us, divided by. This line says divided by. So this problem is $13.70 divided by 5. Now, that's not the way we like to see it. We like to see it like this. $13.70 divided by 5, right? Long division, we need it like this. But we just rewrite it, okay? We can write it in a different format, but this is another way to show a division problem. Just remember that little voice speaking out from that division bar saying, divided by. This means divided by. Okay, so now we're going to remember the steps for long division. You learned this, I know, a long time ago. I'm just reminding. The first thing we do is we estimate. And we're going to do this together. I'm just going to write them all down now. We'll break our hands. We estimate. We multiply. I like to imagine your heads all bent. I know you guys are mostly watching this together. Let me remind you that it's perfectly fine to watch it together. I think it's great that you're doing that. But I also know that when you put 5 12-year-olds or however old you are and however many of them you are, when you put that many almost teenagers in the same place at the same time, math isn't always going to be the thing that everybody pays the most attention to. Do you know what I'm saying? So go ahead and watch it, but just remember that you can go home and re-watch parts or all of this if your attention, let's just say, drifts a little during class. You know, I know I'm riveting, but sometimes it happens that students pay attention to something other than me. Oh my gosh. Multiply, subtract, and bring down. I'll give you guys a minute to catch up. I've told you a million times, you can pause me anytime you want to, but I'm also trying to just breathe a little bit and not go so fast. All right, so these are the steps for long division. This is what we're going to use, okay, for this process. All right, so we also notice, shoot, we've got a decimal in here. We have to deal with that. Now, there's two different rules. One, the most complicated rule is if there's a decimal in the outside number. Well, we don't have that problem. There's only I think this one's the dividend and this one's the divisor. Those are weird words. It's like the minuend and the subtrahend. Ugh, yuck. The answer in a division problem is called a quotient. And that's the one I want you to make sure you know. The quotient we'll write up there. Okay, when the decimal is only inside the box, we just copy it straight up, and now we can ignore it, all right? That's an arrowhead. It doesn't look like one. There. Okay, how many times does 5 go into 1? It doesn't. How many times does 5 go into 13, right? I always just start with one digit, see if you can get anything, then go on to 2. 5 into 13 goes twice. That's my estimating. Now I'm going to multiply. 2 times 5 is actually 10. Cool, I subtract, I get a 3. Now I bring down the next digit. 5 into 37, it would be 5 times 7 is 35, right? That's our closest estimate. So I write a 7 here. Now I actually multiply. 7 times 5 is 35. Subtract 2, bring down the 0. Remember, once we get the decimal established, we can bring down zeros all day, right? I can just keep writing them. We don't need to because John was kind to us, but we could. 5 into 20, that goes exactly 4 times. 4 times 5 is 20. I subtract, yay, it comes out to 0. That's like a sideways equal sign. It comes out to 0, so this is our final answer. 2.74, and we should put a dollar sign on it because it was money. Okay, cool. All right, flipping. Yay. Checking to make sure I'm still in the circle. That ring light makes a weird reflection on my table. Okay, let's do another long division problem. Example 4.4. This one, John gives to us, he tells us to divide, and then he writes it like this. Okay, that looks more familiar, right? This little dots over the sign thingy. And someone pointed out to me, or I read somewhere, this symbol actually is a notation that reminds us. Do you see how this looks just like this? If you put the first number in the top dot and the bottom number in the bottom dot. So this symbol that we think of as division actually is a picture of this kind of division presentation. Isn't that kind of cool? The symbol shows us how to arrange the numbers. So anyway, this all means the same thing, but we don't want it either one of those ways. We want it like this. Right? Okay, so no decimals in this. We don't have to worry about that. And we're just going to do our 4-step process. This one's a little trickier though, because 47, I don't know my 47 times tables. Do you? I bet you $50 you don't, unless you happen to have 46 siblings. But you know, that you've got other problems if you've got 47 kids in your family. So I'm not going to worry about that. What we do is we round to the closest whole number, and I want to round this one to 5, okay? So for our estimating purposes, we're going to use 5 as our estimator, all right? And I'll show you, we have to play with it a little bit, but maybe you've got a feel for this already. Okay, so how many times does 5 go into 2? It doesn't. How many times does 5 go into 21? Oh, that would be 4 times, but it's actually 50, not 5, right? So we need one more digit. So I'm saying 5 goes into 21 4 times. I write the 4 here because I'm going to start multiplying and I'm going to need to use all 3 of these digits. 4 times 7 is 28. 4 times 4 is 16, 17, 18. See how I did that? It takes some guesswork. You can do little calculations on the side, like if you're not sure if maybe 5 would go in, you can just multiply 47 times 5, right? If I thought maybe 5 will fit in. I could do this over on the side. And I'd see 235. Oh, I've only got 218. So 5 is too many times. I'm going to go down to 4. Right? So feel free to make notes. You don't have to erase them or feel shame around them. You're doing your work by hand, so you can make little chicken scratches over on the side to help figure out what you're doing. All right, but I'm going to subtract 0, and I know that's 3. I'll bring down that 3, and I'm ready to start again. Okay, I'm rounding it up to 5. How many times does 5 go into 30? That would be 6 times. When I multiply it, I'm going to have an extra decimal place, so I'm going to put the 6 there and hope it all lines up. 6 times 7 is 42. Squiggle that carrying out. There's 4. 6 times 4 is 24, plus 4 is 28. Okay, that was a good estimate because we're under, right? We didn't go over. If your bottom number goes over, then you estimated too much. All right. And we're going to subtract 1, and I know that's 2. Now, there are different things you can do when you get to this point. You can keep dividing. And we would use decimals, right? I could put a decimal there, and I could start bringing down zeros. And I'd put a decimal in my answer. Or, that's one option, or we can write as a remainder, and in that we would say our answer is 46, and then we say R 21, right? That stands for remainder. Or the other thing we can do is write as a fraction. And that looks like this. We'd write it as 46 and 21, the 0 wouldn't be there, 21 over 47, okay? So there are 3 different ways we can resolve a division problem that doesn't come out even when we get to the end of the numbers as they're stated. We have 3 options. In this case, we look at the answer and we see John chose to write as a remainder, okay? This is kind of the easiest way. This is the next easiest, and that's the one that involves more work. Boo! We don't want more work, do we? We want to keep it real and keep moving. Okay, now we're going to combine multiplication and division patterns. So just like we did with addition and subtraction, we're going to look at some problems where we have missing pieces, and we're going to have to use our brains to figure out how to use multiplication and division to resolve the mysteries of these problems. These, I mean, you might not like them because they make you think, but I think they're more fun than a lot of other problems. 12 times n equals 168. All right, this is a factor. That's a mystery factor. That's the product, right? Just like I've said before, sometimes if you're not sure what to do with these problems, if you just choose some easier factors and set it out, that will help. So for example, I'm going to say, okay, 3 times 4 equals 12. Or I can say 4 times 3 equals 12. Then I can also say 12 divided by 4 equals 3, and 12 divided by 3 equals 4. So this kind of helps me remember what the heck I'm doing. So I have a problem that looks like this, but I'm missing one of these factors. So I see, if it wasn't obvious to me before, if I take the big number, the product, and divide it by the one factor I do know, I should get the answer. So 168 divided by 12, right? I'm using this style. I'm going to write it like this. That will equal n. But in order to actually solve that, I need to write it in this format. I call this a division box. Okay, so now we're ready to figure out how many times does 12 actually go into 168. Maybe you know your 12 times tables by heart. I'm pretty sure I know the answer to this, but let's go ahead and just do the long division. 12 into 1, no va. That's Spanish where it doesn't go. 12 into 16, that goes once. We multiply, we subtract, and we bring down. I did it so fast, I couldn't even say it. All right, now we're ready to begin again. 12 into 48, 4 times 8, 4, subtract 0. Comes out even, right? Yay, thank you, John. So that tells us that our missing factor was 14. Make sense? And that's the right answer. Okay, I don't think I did that. This is the right answer over here. All right, flipping again. So this was a multiplication problem with a missing factor. We used division to find it. Let's try another one. Let's see how many more problems there are. There are 2 more. Okay. Example 4.6. Find the missing number. And this one looks like this. Okay, that looks confusing at first, but then we remember that this line always says divided by. So I'm going to rewrite this into a format that looks more comfortable to me. 64 divided by A equals 4. All right, I feel better now that I see it in this format because I'm more comfortable with it. So now I go, okay, this is the product, this is the ending number, right? And this is one factor, and this is the other factor. These guys can trade places. I can rewrite this as 64 divided by 4 equals A. And that gives me a problem that I can actually solve, right? So again, there are not rules with these problems. You have to keep your head about you and use logic to figure it out. Okay, 64 divided by 4. 4 into 6 once. Multiply to get 4, subtract. We get 2, we bring down another 4. And it ends up to be 16. So we can say that A equals 16. Yay. Make sense? All right, and then there's one more. Let me just flip. Example 4.7. Find the missing number. B divided by 3 equals 15. Now, if it's late, and this is toward the end of your homework, and you're sick and tired of it, and you're ready to go play Frisbee with your friend who lives down the street, or, you know, just about anything is up on your schedule, you're going to rush through this. And it's really easy to go, oh, 15 divided by 3, that's 5. B equals 5. Except wait, these are the factors. This is the product, right? This is the big number. So some big number divided by 3 equals 15. These are both the factors. That's a factor and that's a factor. This time it's the product. That's, whoops, I spelled it wrong. Product. This is the product that's missing. So we should rearrange this into a multiplication problem. 3 times 15 equals B. Make sense? That's the one we're missing. the product. These two are the factors. And so 3 times 15, I can do that in my head. B equals 45. All right, the moral of the story is use logic. Try not to rush any more than you need to. We are doing, let me just draw you a quick chart. This is the last week, the last lesson of the last week that we'll be using our slower pace schedule. Next week we'll move into our normal pace, which we'll do for the rest of the year. Lesson 3. First, you did the odd practice and problem set. Then you did the even problems. For some reason, in this book, Algebra 1/2, they don't give you, John does not give you the answer to the even lettered practice problems anywhere. The odd ones are in the book, but he doesn't show them in the solutions manual, and I don't get it. But again, my rule of thumb is this. If you can't find the answer, don't work that problem. It's a waste of your time. Okay, so you probably have already done these, I'm hoping. Now you're ready to do lesson 4, so I want you to do the odd practice. Remember, it's letters, but figure it out. It's A, C, E, and problem set. And then for your 4th homework session, you'll do the even problems since you can't do the even practice. All right? Keep checking your answers as you work each problem. I know it's kind of a pain because you have to keep flipping back and forth, but it's worth it. It's all good. Let me just show you the practice problems. Here we're practicing multiplying. A dot means multiplication too. We didn't talk about that. Division, division, decimals go straight up. And then here you have some of these puzzly ones. Find the missing numbers. All right? And then on into the problem set, which as we go on, there will be a little more variety in these. The first couple lessons are kind of like we're doing the same thing 100 times in a row. Okay, very good. I will be checking in with you guys. You'll be checking in with me. Let me put it that way. I want you to FaceTime me on Friday between noon and 3 p.m. Unless you've made other arrangements with me, this is the block of time on Friday that I want to hear from you, and I want you to allow 15 minutes in your life to check in with me. If everyone calls at once, I will let you know at the beginning of the call, oh my gosh, everyone just called 2 seconds before you. And if you want, you can hang up and call me back later. But FaceTime me. I'm working on getting a computer that is actually up to date so I can Zoom and then we can all talk at once. But for now, FaceTime, 15 minutes on Friday. I will talk to you then. Thank you. Goodbye.